Hi, welcome. This video will lead us to the demo on the design of mutually aware optimal pricing and load balancing strategies for grid computing systems. In grid computing systems, the load balancing and the pricing is very important. It must satisfy the client and the service providers. The price and the load in the resource are dependable to each other. The pricing have to give revenue to the service providers and the client also. The job submitted in the resource by the client should not take more for execution. So the workload analysis is very important. By load balancing, only jobs are scheduled in resources. First of all, we have to create the jobs. These jobs are executed in the resources. So this job creation is very important. These jobs are submitted by user. So we have to create user. Using these users only, we submit the jobs to the resources. Then we have to create resource. These resources are used to execute the jobs submitted by the users. So the resource is also created. It is very important for execute the jobs. And then we have to find out the average service rate. This average service rate is find out for the jobs. And then the pricing per unit. This pricing per unit is find out for jobs. And then the load balancing. In load balancing, we have to find out the quadratic function. In that, we have two methods, that is global approach and greedy approach. In the global approach, we find out the Lagrange multiplier, and also like in the greedy approach, we have to find out the Lagrange multiplier also. Using this global approach and greedy approach, we apply the expected cost and we find out the expected cost and expected response time. Let us see the demo on the design of mutually aware optimal pricing and load balancing strategies for grid computing systems. Now press enter. In this, first of all, we have to create the number of jobs. These jobs are executed in the resources. These jobs are submitted by the users. So that only we have to create the users. These users submit the jobs to the resources. Then press create and then press next. Now we have to create the resources. These resources are used to execute the jobs submitted by the users. Now we are creating the resources with ID and MAPS rating for each resources. And then there is an intermediate between the resource and the user is broker, that is the cloud broker. The jobs are also called as the gridlets. Now press next. Now we are using the optimal load balancing method. In optimal load balancing method, the average service rate is find out for all the resources, and then the pricing per unit. The pricing per unit is also find out for all this. This is the average price per unit, and then press next. In optimal load balancing, we are load balancing all the resources. So we have to find out the two variables, that is S1 and S2. For that, press get and then press load balancing. Now the optimal load in the resources are find out and press next. In optimal pricing theory, the price of the dominant user is calculated. For that, press get. Using this, we can know about the price of the dominant user. And then we have to find out the quadratic function. This quadratic function needs four variables. They are a, b, c and pi value. First of all, we have to find out the variable a, and then we have to find out the variable b. Then finally we are find outing the variable c. Using these three variables we are calculating the pi value. This pi value is also a input for the find out the quadratic function. This quadratic function is find out for the resources, and then press next. It is the global approach in load balancing solution with pre-assigned rates. In global approach we are find out the cost. This cost is calculated for all the resources, and then we are using the Lagrange multiplier. This Lagrange multiplier is used to find out the balancing cost. This balancing cost is calculated for all the resources, and then press next. In load balancing solution with pre-assigned rates we are using greedy approach. In the greedy approach we are find out the cost for all the resources. Using that we are find out the cost, and then we are using Lagrange multiplier. This Lagrange multiplier is also present in global approach, and in greedy approach also we are using the Lagrange multiplier. Using this Lagrange multiplier we are find out the balancing cost. The balancing cost for all the resources are calculated, and then press next. In pricing solution with pre-assigned rate we are comparing both this global approach and greedy approach. For that we have to calculate three variables. These variables are a, b, c. We have to find out the variable a for global approach, and then we have to find out the variable b for global approach. Then finally we are find out the global approach value c. Then we are using the greedy approach also. For that we are find out the variable a, and then we have to calculate the value for b value, and finally we are calculating the variable c. Then press next. It is the pricing solution with pre-assigned rates. In this we are calculating the expected cost of the resources, and then in expected cost is not enough, so that also we have to find out the response time. It is the expected response time of all the resources. Then press graph. It is the comparison graph between existing and proposed methodology. Thanks for watching this video.